Hello, I'm Neeraj. So today I will explain the concept of zero shot strategy that we can apply with large language model based RAG. Actually, these days people claim that they had developed a system which are generalizable, highly generalizable, means it can work on some novel things which are not in your collected contextual documents that you used with RAG based techniques to answer any questions to get a support so that LLM can get a better answer for your queries. So in that case also their systems are working better. It is more generalizable. So many claims are there. I found that it is very easy to use zero shot strategies here in the RAG with RAG front, and it is very easy to answer such questions. And I found that most of the techniques that people utilized as a background of zero shot strategies mostly people developed before 2010. I means a few strategies are there which use some graph neural network concepts, but others are just old strategies with large language models. So, but here I will try to establish a basic flow like how we can achieve. So, what is the basic common flow of all such systems which claims a zero shot strategies with LLM-RAG? So, that we will explain, that I will demonstrate through the code. So, actually, zero shot learning refers to the model ability to perform tasks without having any explicit examples of task during the training or in prompt, means there should be no such kind of hint or examples either in your collections or in prompt. And even after that, model will be able to understand your queries and will be able to the desired output. So the main component here is like we are not providing any example, means when a given task is given to the model, it receives only the task descriptions or query without any specific example to guide its response, means it should not belongs to that class for which or topic for which we want the exact response. So this is the main thing. And as I said, that generalization is the main area. So I will just go through the flow of this system, such systems. So all such systems flow is very simple and like the knowledge graph and knowledge hypergraph based RAG system that I already discussed. So the main component is like we use some our private data. So why we use the knowledge graph and hypergraph based RAG here also? Because in that case you can handle the complex relations in the documents. Even if your source may be, even if you are using heterogeneous sources of informations, it will work and give the better results. So this is the main reason behind the combining graph or hypergraph based RAG with zero shot strategy. So if you go through my previous tutorials, then you will easily understand all those flows. If you are not going, just I will briefly explain. So first take your data that may be from that may be your big private data coming from same source or maybe multiple heterogeneous sources. So here we are just considering the text data and we are using depending upon LLM only to extract the knowledge graph or knowledge hypergraph. Then this is our knowledge graph triplets. We apply the text embedding strategies to embed the text and store it in vector database. Here we are using ChromeDB as a vector database. So this is the offline process because your data set size may be too huge. So all the process will take a time. So create it and store it offline. Online part will start from here. Suppose you have a user query. Now what is the difference? In our example, I have used the private data that is related to bear which are living in jungles and a lot of different places, but not polar bear. But we are querying about polar bear so that LLM can understand from our context and answer for polar bear, not for traditional bear. So this is our question. So our prompt or query will be related to polar bear, but our private data is related to bear, but it doesn't contain any instances of polar bear, or any hint related to polar bear. So after getting the query, as I discussed earlier, either we can extract triplets from the query, either we can extract more meaningful information from the query by following the rule of zero sort, or we can use the same questions or same text, apply the same text embedding, and then query the vector database. So when we will query the vector database, it will give some instances, it will give some knowledge graph triplets which shows a similar things in a different domain, in a different area. So that will help us or guide the large language model in getting the answer for a different domain. So for example, suppose I say like what how the polar bear look like. So in that case, it will identify that how the bear look like. So polar, because polar information is not here. So in that case, when we get the cosine similarity and extract some top 3 or 4 k nearest neighbor, top 3 and 4 the highly similar queries, then we will get some things like how the bears look like in a natural environment, in non-polar environment. So it will take that information in the embedded format, it will use the query as a prompt in the embedded format and pass those things to large language model and get the answer. So the entire technique will work like a zero sort strategy. So let us see how it is possible through example, through a working example. So in this case, I have used the Olama package. So you can directly download the Olama package from here, olama.com, for Windows, Linux or anything. And for large language model packages, you can use its GitHub site, and you can see that just by running this course, you can directly download those packages. There are multiple packages. I have used Llama 3 8 billion parameter package to just demonstrate this. You will need some some document or text embedding packages. So I have used the BERT large text embeddings. So that is MXBI embedding large. You can run this code to download this package. So this is very simple. Once you complete all those things, install the ChromaDB. After that, I have taken the documents, same documents related to bear, not polar bear. After that, we extracted the triplets for the bear, not polar bear, same documents. So these are our knowledge graph triplets. So after that, as I discussed that how we can use the knowledge graph with LLM-RAG. So we will use those triplets, convert it into simple text format. For example, if we say that bears use shelters, so we just replace the comma with a space so that it will look like a simple text fragment like bears use shelters. So similar way we convert the entire text. So then it will look like small text fragments with huge concentration of information. So once we get that, we will prepare a ChromaDB client database. So our database temp, inside that is database temp, I'm just using the full path, absolute path. You can use relative path also. Just for simplicity, I am doing all those things. Then you can name your database name like BRKG ZS zero sort. And after that, for metadata, actually we don't have any metadata like we generally use with movie things like movie genre, action, horror, like that. But so we just fill. Now for each of those knowledge graph triplets, so here we have knowledge graph triplets, KG triplets. So we will convert each triplets into the text, and for each text we will just embed and add it in the collections, means we will add it into the vector database after embedding. So the process is same like we discussed here. After that we have a query, how polar bear's body looks. So in that case we will apply the embedding for that query also. So we embedded that prompt also. Once we embedded this prompt, we will go through the result. We will identify the similar text in this context, even if it is not from the same domain. So it will identify the similar text. This query will calculate the cosine similarity, and based on that it will identify the similar knowledge graph triplets. So we just wanted 4 such kind of results. So after that we will try to we just try to print the results, what kind of results we get. That 4 results, and we actually are getting the 4 knowledge graph triplets. So the task will be to how we can collectively use those 4 knowledge graph triplets. So one possibility is to just embed each triplets, just concatenate each triplets one after other like a text, and add concat and add a space between them. So the same way we concatenate, and then we fire the query by using llama 3, and we want the answer for our prompt for the given data. So our data is this result. So once we run this, see what happens. Finally I got the result in few seconds. I surprised to see the speed even in just a 16 GB RAM system. So here you can see that we have tried to print the results. Results are like just 4 nearest knowledge graph triplets which have the maximum cosine similarity with our prompt. So here we got those results. So we can see those things, like it says that first, modern bears have a stocky legs, modern bears have a small round ears, bears can be diurnal, bears can have excellent sense of smell. So these are the outcomes that 4 knowledge graph triplets it identified, which may be the system thinks that it may be near to these questions. And based on that, what answers we got, that based on the prompt that modern bears have, I would infer that polar bear's body might look like this. So it says that stocky legs, polar bear's legs is likely to be short and sturdy. These adaptations allow them to support their large bodies on ice and snow. Wow. Their large size is likely to ability to harsh an Arctic environment where food is scarce. So I think it captured the sense, and it had given almost a means very accurate answers for our questions. So I think it is working. So zero shot concept is working. That we realize. So thanks for watching, and hope you have enjoyed this tutorial.